Hello, so I want to finish chapter 4. Let's share the code together. Let me share my screen and then we can code together. So the first thing I want to check is universal formats. So the universal formats actually is that we can do some like computation on array. So it's like we can think we actually can think in the arrays as fast vectorized wrappers for simple functions that take one or more scalar values and produce one or more scalar results. So see, we can use square root, and um, we can use this to get the log of this every element in this array. And we can also, yeah, find the maximum number in these two array. So, and the next thing I think is very interesting is that, so this like modf um, function actually can returns the fractional and integral parts of a floating point array. So you can see that A is like this, and then we actually store the fractional part in remainder and the integral parts integral parts in uh, integers. So here is the result we have. And so we can also do the square root of a of array in this way. And yeah, remember what we do before. Okay, they are the same. Actually, um, these functions actually accept an optional out argument that allows them to operate in place on arrays. So um, if we first run the square root, and do you think array is changed or not? Actually, array is still like array, right? But if we want to replace the old one, we can write the old one here in this function. And then let's check what's A right now. See, A is changed. So that are all about um, this universal formats and sorry about that fast element wise array functions. There are a lot of these kind of functions like absolute, ABS, square root, square, and exponent, and log, and sine, and ceiling, and the floor. So actually there are lots of things that you can try, and I will not um, put them all here. Sorry, so yeah, so let's go to the next part, which is array-oriented programming with arrays. Array-oriented. So how to understand array-oriented? Actually, it means that so use NumPy arrays make us to express many kinds of data processing tasks as concise array expressions that might otherwise require writing loops. So this practice of replacing loops with array expression is referred to as vectorization. And so in general, vectorized array operations will often be one or two orders of magnitude faster than their pure Python equivalents. if the biggest impact in any kind of numerical computations. And so let's check out a function which is np.meshGrid. It takes two 1D arrays and produces two 2D matrices corresponding to all pairs of x, y in two arrays. So here is the points. Okay, this one will create 1,000 equally spaced points, and then we use NP mesh grid. So what is XS and what is what YS? Okay, it's like this. And so in now we can actually evaluating a function is a matter of writing the same expression you would write with 2 points. For example, we want to get square root of x s power 2 and y power 2. Okay. Ys, right? So what did we get? What we get here is like this. Let's go to the next part, which is expressing conditional logic as array operations. So I will add a cell and input expressing conditional logic as array operations. So here actually is some how to use array to like set conditions to find the things you want. So for example, here are 3 arrays, and so I have what I want to get is I want to take a value from X array whenever the corresponding value in this one, in the third one, CON is true, and otherwise take the value from Y array. So what should we do is like this. Okay, result is equal to X if say else Y, and for X, Y, C in zip. Remember, we have used zip in the tuple, right? In the tuple part. X array, Y array, CON. Okay, that's all about them. And what will be the result? Okay, 1, 2, 7, 8. 1, 2, 7, 8. So because the first one is true, so we will choose some the first first elements from X array, and then the last 2 elements will come from Y. So that is the condition, and we can also use like np.where then con X array Y array. See, we have the same, we can have the same result here, right? Then the second, so np.where is also a very important thing, important function, important method that we need to remember. A typical use of where in data analysis is to produce a new array of values based on another array. Suppose you have a matrix of randomly generated data and you wanted to replace all positive values with 2 and or negative values with -2. So how can we do that? Okay, I will use an old friend, which is A. Okay, how we create A? Yeah, like this. It's in here, and right now A is like this, and what I want is A dot np where, and oh, sorry, it should be A is bigger than 0, then should be 2, and otherwise. Okay, see, that's the result we want to have. And we can combine scalars and arrays when using np.where. For example, we can replace all positive in array with a constant 2, like, I mean, we didn't change anything in the original A, but just change anything that is bigger than 0 into 2, then others are the same. See, so everything is less than 0 are still the same. So let's go to the next part, which is mathematical and statistical methods. So that part I don't think is very hard. And so I will just take one example here. Math. Okay, give it a very concise title. So for example, for this A, and there will be like, okay, I want a mean. So that's how we get a mean, and we can also get the like, sum, and we can also get the outcome sum, which is cumulative, right? Cumulative sum up. Okay, so let's go to the next part, which is like methods for Boolean arrays. So for this part, actually, when Boolean values are restricted to 1 and 0 in the preceding methods. So sum is often used as a means of counting true values in the Boolean array. There are two additional methods, any and all. So what we can use is, yeah, in the Boolean is any or all, and any tests whether one be quiet, okay? Whether one or more values in an array is true, while all checks if every value is true. Then let's go to check sorting. So for sorting part, which actually is pretty the same as before. So for sorting, we can use dot sort to sort the array, and we can also sort each one-dimensional section of values in multi-dimensional array in place along with the access by passing the access number to sort. So the top level method np.sort returns a sorted copy of an array instead of modifying the array in place. And next part we will check is unique and other set logic. So np, oh yeah, if we want the unique like number, unique values in an array, then we can use unique, np.unique, then parentheses that we can put in that array, and we can or also we can use set to get the unique value. And another function is called ab dot in 1D. So it tests membership of values in one array in another, returning a Boolean array. So it is to check that, okay, if these values are in that original array. So the next part I will check is file input and output with arrays, and what I'm looking at. So I think I cannot finish this part, so let's stop here, and then I can finish the chapter 4 in next video. Bye.